Welcome to Easy Gates Gate 22 electrical paper solutions. Next problem 21. So almost in the point boundary of circuits and power systems. Okay, but with the knowledge of circuits, still you can connect to this three-phase problem. Okay. So what is given in the given circuit? A three-phase star connected unbalanced load is connected to a balanced three-phase power supply having a voltage 100 root 3. Again, it's a line voltage with a phase sequence ABC. So what is given is VL is given 100 root 3 volts. Therefore, the V phase will be equal to 100 volts. Okay, so given ABC sequence, I can take VAN, A with respect to neutral as, that is here I'm defining VAN. This is VAN. That's of course your EA. This is plus minus. He has mentioned, okay, what he has mentioned, the three-phase star connected unbalanced load is connected to a balanced three-phase power supply. Find that. What is the next point? The star connected load as ZA is equal to 10 ohm. This is purely real, so but still you can take in polar form 10 angle 0 degree ohms. ZB is given, that is 20 angle plus 60 degree ohms. Okay, that's inductive. The value of ZC in ohms for which the voltage difference across the nodes N and N dash is 0. That means voltage difference. There is no potential difference between N and N dash. Since it is an unbalanced load, N dash, okay, maybe a different potential if the neutral current is not equal to 0. Okay, right? If the current is not balanced in this KCL. So let me assume this neutral is the reference, that's a ground. So if I take this neutral as 0 and he is saying that no potential difference means this neutral also will be treated as a 0. If that is the case, I can help myself. This is going to be A phase and this is also going to be my A phase. So the voltage across this will be VAN. I can take the phase voltage assuming the neutral point of this star is equal to 0 volt. And this potential will be VBN because it is connected to the B phase. So this is going to be VBN. So I can simply balance the KCL at this node. Sum of all the current should be equal to 0. That's a requirement. How we can play? So by taking this as a reference, it is 0 volt. So this is your A phase. This is your B phase. This is ZA given 10 at an angle 0 degree ohms. ZB given 20 at an angle plus 60 degree ohms. So now you know this potential as VBN, and instead of N star, N dash, I'll take it as N because identical potentials. Okay. Yes. So I'll go for this current as I1, this current as I2, and this current as I3. So algebraic sum of all the three currents must be equal to 0. I1 plus I2 plus I3 must be equal to 0 to get the neutral current. Okay, so then this is possible. So this point is C. Okay, so I3 is a C phase current, I2 is a B phase current, and I1 is a A phase current. So instead of ABC, easily 1, 2, 3, I will assign corresponding phase currents. Okay, so I1 we can determine. What is I1? I1 is the current in the A phase, that is nothing but VAN divided by the impedance ZA, that is 10 angle 0. We can determine. I2 also we can determine similarly. What is I2? The B phase current. It is VBN divided by the impedance 20 at an angle 60 degree ohms. Yes, let us evaluate them. So from this, what is I1? I1 is equal to VAN. So ABC sequence, you know the phase voltage, VAN is equal to 100 at an angle 0. VBN is equal to 100 at an angle minus 120, all in volts, remember. And VCN is equal to 100 at an angle minus 240. Even you can say plus 120, no problem. What is I1 then? It's VAN, that is 100 at an angle 0. 100 at an angle 0 degree volts divided by the impedance 10 at an angle 0 degree ohms. So result is going to be 10 amps. So it is nothing but formally 10 angle 0 degree amps. That's your I1, or 10 plus J0 amps in rectangle form. Similarly, what is your I2? I2 is equal to VBN. What is VBN? VBN is given 100 at an angle what minus 120 degree volts, the whole divided by it's 20 at an angle 60 degree ohms. So what is that current you're getting? So 60 degree to the numerator will be, so 100 by 20 will be 5 at an angle minus 180 degree amps you will get, which is nothing but minus 5 plus j0 amps in rectangle form. Okay, you got I1, you got I2, and who is only unknown? I3. Once you know the current I3 and you know this potential difference is what? VCN. So then this is plus minus, current is going from C to N. So then I can say the unknown impedance is equal to VCN divided by the unknown current I3. VCN is known. Once you find I3, then we can determine the impedance in the C phase. Okay, is that C? So that the current is getting balanced. Okay, it's going to become a three-phase, three-wired system because the neutral current is going to become 0. Yes, as per the KCL, we can find out I3 now. So what is I3 from this? From this KCL, what is I3? I3 is equal to minus of I1 plus I2. Okay, you just add I1 and I2. I1 is 10 plus J0. I2 is what? Minus 5 plus J0. So I3 is going to be minus of, it is 10 and this is minus 5. That's all. So it's going to be real. It is going to be minus 5. It's going to be minus 5. I3 is going to be minus 5. So then I can say I3 is equal to minus 5. It is nothing but minus 5 means 5 at an angle minus 180 degree amps will be the current. Okay, usually what it means, it is minus means it is going to exist in the opposite direction. Instead of C to N, it is existing from N to C. But fine, already we defined ZC, will go for that. Okay, so therefore ZC is equal to, what is that? Phase voltage VCN. VCN is well known, that is 100 at an angle minus 240 degree volts. It's like Ohm's law only, the whole divided by your current. It is 5 at an angle what? Minus 180 degree what? Amps. So as a result, what we get 100 by 5 is going to be 20, and 20 at an angle, what we get? Minus 240 plus 180 is going to become minus 60 degree volt per amps. It is going to be ohm. So that's a impedance. Okay, needed for ZC to make the neutral current 0 or to ensure there is no potential difference between N and N dash. Okay. So that's a interesting problem. So the best possible answer is 20 at an angle minus 60. Okay. Yes, that's a correct answer. If you want, you can verify the steps or substitute 20 angle minus 60 and ensure you strike this balance. Okay, KCL balance. Yes, that's a good problem, and hope you enjoyed this content. Okay, we'll update you the next problems soon. So subscribe our channel. Okay.